For loops. In this video, we will learn to write for loops in Java. As was learned during the Python unit, a for loop is a body of statements that executes a predetermined number of times. In Java, to write a for loop, we start by writing the keyword for, then open parentheses. The next step, initialize the loop control variable. The loop control variable controls how many iterations the for loop will execute. Next is the loop condition. The loop condition gets checked before each iteration of the for loop. The iteration will only execute if this condition is true. Then there's the loop increment step. The loop increment step executes after each iteration of the for loop. Its purpose is to increase or decrease the loop control variable by a specific amount after each iteration. After that, we close off our parentheses, then type the open curly bracket, which signals that we're about to enter the loop body. Inside the loop body, we indent, then type our conditional statements. These are the statements that will execute during each iteration of the for loop. After typing our statements, we type the closed curly brace to indicate that we're at the end of the for loop. Let's take a look at an example of a for loop inside our Java code editor. In this for loop, we initialize our loop control variable to 0. We set our loop condition to I is less than 3, thus making it that the for loop will only perform an iteration if the value stored inside I is less than 3. Then, after each iteration, we're going to increase the I variable by 1. Then inside our for loop, we're going to print out the value of the I variable, concatenated with a space and the word hello. When this for loop executes, first 0 hello gets printed out, since 0 is the initial value of I. Then 1 hello gets printed out, since 1 is the next value. Then 2 hello gets printed out, and then that ends the for loop, because after that iteration, I becomes equal to 3, which at that point, the loop condition will now be false, since 3 is not less than 3. Now consider this for loop example where we change the loop condition to I is less than 5. Everything else is kept the same. So when we execute this for loop, first 0 hello gets printed out, then 1 hello, then 2 hello, 3 hello, 4 hello, and then that's the end of the for loop, since after that iteration, I will become equal to 5, thus making the loop condition false. Now suppose we change our loop condition to I is less than 10. This, of course, will result in even more iterations of the for loop being executed, since now it's going to take longer for the loop condition to become false. Only once I becomes equal to 10 will the loop condition become false. Now, suppose I change the loop condition such that instead of using the less than alligator, I use the less than or equal to alligator. This will result in one extra iteration being performed by the for loop. The reason before that is because, unlike the previous example, where once I became equal to 10, the loop condition became false, in this example, when I is equal to 10, the loop condition is still true because 10 is technically less than or equal to 10. So the loop will execute one more time. It's not until I becomes equal to 11 that the loop condition finally becomes false. Now suppose I change the alligator in the loop condition to the greater than symbol. Remember that before each iteration of the for loop, the loop condition gets evaluated to see if it's true or false. Only if the loop condition is true will the iteration be performed. Well, if I is initialized to 0, what will be the value of the loop condition at the very beginning of the for loop? It'll be false because obviously 0 is not greater than 10. So in this case, the for loop isn't going to perform any iterations because the loop condition was false from the very beginning. Thus, no output would get produced by this program. During the Python unit, we expressed that 0 does not have to be the starting point for our loop variable. The same goes for Java for loops. In this example, we initialize our loop variable to 1. We then adjust our loop condition such that the for loop will execute only when I is less than 10. Then we increase I by 1 after each iteration. Inside the body of the for loop, we once again print out the value of I followed by the word hello, thus giving this as our output. Once again, as you can see, I started at 1, increased until it reached 9. once it became equal to 10, the loop condition became false. Notice how in this example, instead of 10 iterations being performed, which was the case back when I was initialized to 0, in this example, only 9 iterations got performed. Now suppose we initialize our loop control variable to 8, all the while keeping the loop condition and the loop increment step the same. In this case, we get 2 lines of output. Only 2 iterations get performed. So as you can see from these 2 examples, clearly changing the initial value of the loop variable affects the number of iterations that the for loop will perform. Now, in the Python unit, we also learned that +1 is not the only increment that can be used for a Python for loop. The same goes for Java. Here in this example, instead of increasing I by 1, we increase I by 2 after each iteration. So if we initialize I to 0 and loop for as long as I is less than 10, this will be our output. Notice that the value of I is increasing by 2 every single time. Okay? Also notice that because I was increased by a different amount, this also affected the number of iterations. Only 5 iterations got performed in this for loop. In this example, we increase I by 3 after each iteration, thus leading this to our output. Notice that in this output, the value of I is increasing by 3 every time. Also notice that we only performed 4 iterations for this for loop. Addition is not the only type of increment that can be performed. We can also do multiplication. Here, we initialize I to 1 and multiply the loop variable times 2 after each iteration, leading to this as our output. Any arithmetic operator can be used in the increment step. Addition, subtraction, multiplication, division, modulo, they're all acceptable. Okay? In particular, subtraction comes in handy when you want to count backwards. In this example, we initialize the loop variable to 10. We set the for loop to loop for as long as I is greater than 0. Then we decrease I by 1 after each iteration, thus leading to this as our output. Okay? Notice that the I variable started at 10 and went all the way down to 1. If we want to include 0, then we can modify the alligator to be greater than or equal to 0 so that the loop condition will be true when I is equal to 0. When we execute this for loop, you see that 0 gets printed out. It's not until I becomes equal to -1 that the loop condition evaluates to false.